Earlier in the episode, we have seen how we can create asynchronous code in Java using callable completion service. And now we are going to take a look to another way how we can write a asynchronous code in Java using completable future that was introduced starting from the Java 8. So what's the advantage of the completable future? I have here an example. One of the main advantages of the completable future is that it allows us to have a chain operation. So for example, in this case, let's say we have a scenario when we are fetching a user info, we are simulating a DB call or the API call. So we are fetching the user info here. So we have fetched that. And after that, we need to perform another operation on this user, right? So we need to, based on this user, based on the username or user ID that we have fetched, the second step, we need to fetch the orders, right? Let's say we have an e-commerce application and we need to fetch orders. So based on this result that we have returned here, based on this user, we are fetching order for the user that we have just returned here, right? And the next one is we are fetching all the orders. So we have order 1, 2, 3, and here we are simulating some work. We are putting that thread to sleep. And in the last one, after we finalized of these two operations, so what we do is we are, based on those orders, we are formatting the final output, right? So we are transforming result and we are just printing that the user summary, name, and the orders. So as you can see here, so what we can do here, right? We can also add another, then we can add then another apply, right? So that we can add, let's say we need to do one more transformation here, then we can add then another apply, or then another compose, then another apply. We can do asynchronously. So completable future allows us to do these chain operations. As I said, it's a asynchronous code. So what it means is while this one will be performed, while this code will be performed. So it goes to the database, it fetches the result, then based on that result, it fetches from the another table orders, and then it formats that result the result that we got to the final result. And while it's doing that, so it's a non-blocking, we can perform also other logic here. So in this case, we are just printing main thread is free to do other work. And after that, what we do is we are getting, so this part is blocking. So here we are waiting for our asynchronous code to complete, and we are printing the result here. So whatever the result is, here we are printing. Let's do that. Let's run this code and see that it works as expected. So as you can see here, it starts for fetching user from the database. While it's doing that, main thread proceeds with its logic, right? So let's say we have some logic in the main thread and we don't want to block that. So we are going with the first one, fetching from the database, and then it proceeds to perform whatever logic we have after it, right? So then it proceeds with this logic, and after that we are completing our chain of the operations and we are printing out the result. So that's the advantage of using the completable future. So we have seen so far callable, we have seen completion service, and starting from the Java 8 also we have completable future. These are the ways how we can write asynchronous code in Java. But what are the other options, right? Besides this one that we have already seen. So well, there are not much options in terms of the standard library, but we have the external libraries that are specifically written for writing asynchronous code in Java. One of those libraries is Guava library, which is developed by Google's Guava library for listenable future. For listenable future, it was introduced before the completable future, and it extends future by allowing the callback when the task completes, and also it often used in the distributed system. So for example, here we have an example. We are creating a service. So we are creating a thread pool with the two threads. And here we are creating our listenable future instead of standard future. So we are creating a listenable future, and to that future now here we can add, as you can see here, we can add the callback, right? So whenever this one completes, we want to see the result on success, what to do, or on the failure, what we need to do, what action we should take from our side. And so for the completable future, for the Guava to sum up, it's a predecessor of the completable future. Nowadays, if we want to write a asynchronous code, so usually we go with the completable future. The Guava advantage of Guava was that it was introduced before completable future, and in some cases it was used before. So in some legacy applications, you may still see that. So also it's good for integrating async callbacks. Another framework, another library that is used is Netty. Netty is used for the high performance network applications, for example, for web servers. It's entirely based on the event loops and the async callbacks. Uses its own abstraction. It's called the channel future. So for example, in here I have an example where we are creating a channel future, and in the channel future we are adding a listeners to that future. So where it's used, right? It's used for applications such as gRPC, Spring Web Flux, and Akka. And it's a low level and very efficient. So to sum up what we have for how to write asynchronous code in Java, right? So let's start with from the very beginning. First, we have a thread, we have a future, we have completable future, we have Guava, and we have a Netty. So for those, do they support chaining? Are they non-blocking? And are we using nowadays either application or that from the out of the box, right? From the Java. So for the thread, it's chaining is not allowed. So it can be non-blocking, but we need to do that manually. And the modern use is rare. For the future, it doesn't allow chaining. It does not have it's blocking, and it's also, you can see that in the legacy application. Completable future allows chaining, allows non-blocking, and it's used in the modern applications. Guava again allows chaining and allows non-blocking, and it's used sometimes. So for the Netty, we have again it allows chaining, it allows non-blocking, and it's used in the high performance applications. So for recommendations, when we are decide for one or the other way, for one or the other reason to use a asynchronous code in our application, to use a completable future. It's because it's much more easier, and it started from the Java 8. Java supports completable future. Starting from the Java 8, it was introduced, and for the network IOs and for the reactive systems, we can use Netty.